check the camera. I didn't know it didn't have audio. But I thought it did. Almost every other camera does. All right, well, I apologize for that. So hopefully, anybody check? Do we have sound today? We have sound today. So we got to use my camera, not school camera. All right, we'll apologize for that. Even more reason to come to class. Here we go. Okay, so the last time we did not finish the story problem, so we're going to do those today. So let's say that the gas mileage of a car is given by the equation M, and I'm not going to use S because I hate S. I'm going to use X. -1 over 28. This screen kind of sucks. Pick a different color. Try purple. -1 over 28 x squared plus 3x minus 31, where x is between 15 and 70. Okay, where x is miles per hour and m is miles per gallon. What is the car's best MPG and at what speed? Okay. So, Riley, I don't pick on you near enough. What do you think? Purple's a lot easier to see than black, isn't it? You know? You know what it is? Not even today's quiz. Does that give you any ideas? Anybody got any ideas on how you do this? Cameron?
Would you try to find the maximum?
Find the maximum. That would be a good idea. How would you find that? Oh, I forgot to turn on the camera so the TV so you guys can make sure I'm on camera here. Graph it?
Yeah.
That would definitely be one way. To Eunice, right?
Yeah.
Eunice, do you have any other ideas?
Would you factor it so you do like vertex and then gallons?
So we could factor it, but that looks awfully ugly to factor, right? Not the easiest thing to factor in the world. So two good ideas. Any other ideas? Michael?
Use the vertex formula.
Vertex formula, right? Because that would be a lot easier than factoring that sucker, right? Okay, what is the vertex formula?
B over 2A.
-b/2a, comma, f of whatever number you come up with. Okay? But do you understand why we have that as the y coordinate? We figured out the x coordinate last time in class, right? Even though you couldn't hear it, but if you would have come, you would have heard it. Why? So the x coordinate, because the idea here is, I don't know what this looks like. Let's pretend it looks like this. Okay, let's pretend that's the vertex, right? Okay, so if this is our miles per hour, which is our x, and if this is our miles per gallon, okay, then that is going to be the best speed you can get with the best gas mileage, right? And so if I find the x coordinate, all I gotta, this function represents f, or in this case, m, I guess. So all I gotta do is, well, I know what this is, and if I plug it into here, then that's gonna tell me the y. So that's how the vertex formula is. Okay? All right, so Rory, now that you've had that great help from your classmates, are you studying by yourself, by the way, or do you have a friend that you're studying with? You used to go to math lab. They're paid to be your friend. Okay. All right. You might want to talk to some people in here, like Michael or Lewis or somebody like that, because they seem like they know what they're doing too. All right. So negative b over 2a is negative 3 over 2 times negative 1 over 28, right? The negatives cancel. 2 goes into 28 how many times? 14 times. So I've got 3 over 1 over 14, right? How do you divide those? Flip the denominator, so that's 14 over 1. 3 times 14 is 42, right? Okay, so according to this, the best gas mileage you're going to get is at 42 miles per hour. And at that rate, what will be the miles per gallon? Kakana? You know? All we got to do is use this formula, right? So I got to plug this 42 into where? Inside, well, into this function here, right?
Yeah.
Okay, so tell me what to write.
42.
About negative 1 over 28 times what? X squared, and x in this case is 42. Quantity squared plus 3 times, but x is 42 minus 31, right? So we can plug that in our calculator. And as everybody knows, that is 32 miles per gallon. Okay? So you can drive everywhere at 42 miles per gallon, 42 miles per hour, you get 32 miles per gallon. Just don't do that in school zone. We don't care about your fuel efficiency there. Okay, so stay away from school zones. Okay, questions? We good? Well, this is nice. We got more time than the last class. Okay, all right, let's do another one. Let's say that a hockey team has an arena, has a capacity of 15,000 fans. Okay? At $14 per ticket, they get 9,500 fans. Okay? A market survey says that each dollar ticket price is lowered, they will get 1,000 more things. So A, find a function that maximizes, oh wait, sorry. Find a function that models the revenue in terms of the ticket price. B, what price maximizes the revenue, and what price is so high nobody will come. You could probably put it up at $1,000 and nobody would come, right? But the problem is you could probably do it at the lower price, maybe 500, right? Okay. So now, just for fun, let's you know what we might want to do? If they're selling them at $14 a ticket and they can sell 9,500 tickets, how much money do they make right now at the moment? And you guys aren't telling me I'm off camera. Cameron, and how did you get that? You took 9,500, which is your number of fans, times your $14, and you got, which was the ticket price, $133,000. We will assume that's it. So your revenue basically equals your price times your quantity. I guess that's your quantity, that's your price. Okay? All right, now the idea here is we don't know what price is, right? We kind of have a benchmark of 14 here. So let's set our quantity as X price. Okay? So we're going to make this revenue as some function of the price. Okay? So now we need to figure out our quantity, right? So our quantity we're going to have is 9,500 if this is at $14, right? Okay. But we know that we're going to increase. We're going to get $1,000, or excuse me, not $1,000. 1,000 people are going to come, right? If we take the price of our ticket, $14, and we're going to get that for every X dollars we take off on our fans. Does that make sense? Okay. So let's think about this for if X is 1. So if we take off $1, right? So this is now $13, right? And we're going to get 9,500 plus 1,000 times 14 minus your $1. Okay? So we're going to get 1,300 more fans if we take it down $1, right? Does that make sense? So we're going to get 1,300 more fans. So 13 plus 95 is 10,800 more people if we dropped our price from $14 to $13. Does that make sense? Okay. So this looks like it's a good function, right? So now the question is, we've got a nice function here. And it's basically price times your quantity. Your quantity is just a little bit complicated, right? Okay. Now, what do you notice about this function? If you were to graph it, what would it look like? Does it look like a straight line? What does it look like? Rory? We're on with the R's today, Riley and Rory.
It's not a parabola.
It's not a parabola? Why not?
It's not squared.
It's not squared? What's x times x?
So
It is a parabola.
that's the minimum.
Okay. Is it an upward parabola or is it a downward parabola? Should we vote? Who says it's upward? Who says it's downward?
I have a question.
Who raised your hand twice? Question.
So there's an x at the beginning of the function and at the end,
Uh-huh.
but you put two different numbers in for each x.
Well, here's what I do.
I understand that lowering the price of 14 by 1 would
Yeah, this is for-
1 at the end, but
Sorry.
should it be different variables or?
If it's $13, this 13 and that 13 are the same, right?
Yes. But I'm just saying that if it's the same variable, let's put the same number in for the variable.
So your price, this is your price, this is your quantity. So your price is going to be X, but we can all, it can't be more than 4. So we're using our reference as 14 minus X. Let me see here. So X is your ticket price, right? And we're just saying it can't be, it's going to be 14 minus X. I mean, the idea here is you're not going to spend more than $14 for, or you can't take more than $14 off of your ticket price.
Right.
When you just put 14 minus X, parentheses in the beginning too. Would that be the same thing, but would confuse the variables?
This is your ticket price. Ticket price. This is also your ticket price. Okay?
I think I understand.
Okay.
I think I worked it out in my head.
All right. So the idea here is now that Rory knows this is what kind of a parabola? It's a downward. I've got a negative x squared. If I were to multiply this times that, I'm going to have a negative x squared. So it's going to be a downward parabola, right? And I have a feeling if my ticket price is 0, how much revenue am I going to make? I'm going to make no revenue. So it's probably going to go through there. And we need to figure out how much that would be also. This is going to be our ideal ticket price, right? And our maximum. Okay? Am I off camera again? Close. All right, so how do I find, this is going to be the price of the ticket price, and this is going to be the quantity. Okay? So how do we find that, Hallie? Either the price or the quantity. Yeah, it'd probably be easier to distribute this. Okay? So, here I'm going to come back over here because we're getting kind of far and that's going to give a bad angle. Okay, so I'm going to rewrite the function. And it's going to be r of x equals x times 9,500. 1,000 times 14 minus x. So we'll distribute this through. So this is going to be, let's do this piece first. 9,500 plus 1,400,000, excuse me, minus 1,000 x times x, right? So I can combine both of those and I'm going to get 23,500 x minus 1,000 x squared. So I would take either this or, this might be a little bit easier, that is your revenue function. Okay? Either of those is fine. Now the question is, what do we do next? So we've done part A, we've found our function. What is the price that maximizes the revenue? And I'm going to find that with what, James?
The vertex formula.
Vertex formula. Okay, so that's going to be negative b over 2a f of whatever number we find. So what's negative b over 2a?
Positive 1,000.
Positive, so this is a, right? And that's b?
Negative
Yeah, it's written backwards, isn't it?
23.
Negative 23,500 over 2 times negative 1,000. Those go positive. 2 of those take out 2 of those. So I'm going to get 235 divided by 20, which works out to be what? $11.75, I believe. Okay, so just like we have on this graph, now we don't have miles per gallon, we've got ticket price, and we've got quantity of people, and we've got $11.75. Okay, now we need to find the quantity. How do we find that? Zach?
Put that 1175 back into play.
F of 1175, which equals 23,500 times 1175 minus 1,000 times 1175 quantity squared. Okay? And as everybody knows, if you punch that into your calculator, you should get, oh, it didn't say. No, you have to punch it in. I don't have that. Okay? Now, the last part I want to do, part C, really quick. I know we're out of time. What is the value in which you will raise the ticket price so high you will get no money? That's your x-intercept. So what do I do there? I'm going to set y equal to 0. 23,500 x minus 1,000 x squared. I can factor out an x. I'm going to get 23,500 minus 1,000 x. Okay? So either x is 0, like I said, if you don't charge anything, you're not going to get memory, anything, or 23,500 minus 1,000 x equals 0. Switch that to the other side, divide by 1,000. X equals $23.50. So if you raise it so high to $23, nobody's going to come. $23. Okay? So that's really the limits of your ticket prices, 0 to $23.50. Okay? All right, quiz tomorrow is on all the story problems. We'll see y'all tomorrow.